Okay, here we are back into chapter 4, physical and cognitive development in the first 2 years. So we're looking at the what is the appearance at birth. So when a child is born, commonly known as a neonate, the neonate's the term for the newborn infant up to the first 4 weeks. The skin often looks red, and if born early, the baby can also have a white waxy substance called vernix on their skin, and they may be covered by white fine downy hair called lanugo. And in normal vaginal deliveries, the baby's head may be elongated or have a noticeable point on it, and this is due to the pressure of the birth canal, which squeezes the skull, because the skull is actually very soft, often for several hours during labour. And within a few days, the head fills out again into a more rounded shape, leaving gaps in the bones of the skull. So the gaps are called fontanelles or soft spots, and although they're actually covered by a tough membrane that can withstand normal contact and pressure, it's still important not to have too much contact with that spot. And in fact, you can actually place your hand on a baby's fontanelle, the spot where between all the joins of the skull, and you can actually feel their pulse in that space. Quite interesting. The gaps gradually go over, but it's not until about 18 months of age. When they're born, the average weight is about 3.4 kilos and 51 centimetres long. Their length matches their adult size more closely than their weight does. And growth charts are used to show children's height and weight gain over the time in comparison to other children of the same age and sex. When you're born, if you're born in New South Wales, your mother is given what we call the Blue Book, and the Blue Book is the book that provides all the information of your birth, size, weight, APGAR score, all that kind of stuff. And your mother keeps that Blue Book and continues to record your immunisations and your growth and your length and your weight over the many years. So it's kind of fun if your mother still has your Blue Book to go back and have a little look at that, to see how long you were when you were born, how heavy you were, and how that has compared to your final height. There's actually an interesting statistic, and that is that a boy at 2 years, his height at 2 years, if you double that, usually gives his completed height. So you can compare that and have a look, see how long or tall you were at 2 years old, and compare that to how you are now and see whether that's actually accurate. It is in about 90% of cases, so it's pretty good. So we have a thing called the APGAR score, and the APGAR score helps doctors and nurses decide quickly whether a newborn needs immediate medical attention. It's a scale which consists of ratings used to calculate the baby's heart rate, breathing effort, muscle tone, skin colour, and their reflex irritability. And a score of 0 to 2 is assigned to each of the 5 characteristics, which basically then gives you a score out of 10. Babies rated twice, once in the first minute after they're born and the second after 5 minutes, and they do 2 ratings, as some babies have difficulty adjusting to their new environment at first, but adjust well several minutes after birth. So a maximum score of 2 with a possibility of a total score of 10. And most babies earn a 9 or a 10 by at least 5 minutes. The scoring is broken into groups. 7 or above indicates that the baby's in a healthy physical condition. 4 to 6 at 1 minute, the baby is given immediate special medical attention, and 3 or below indicates that the infant is in serious danger and requires immediate resuscitation and emergency medical attention. So the APGAR score has been around since, as you can see, 1953, and is still used to the present day. And if you watch this YouTube clip, you'll see an example of the midwife performing the APGAR test, or doing the APGAR scale to see how the baby rates. So the development of the nervous system. The central nervous system consists of the brain and the nerve cells of the spinal cord, which together coordinate and control the perception of stimuli as well as motor responses of all kinds. The brain deals with the more complex functions, and the brain develops rapidly from just before birth until well beyond the child's second birthday. So at birth, the brain is about 25% of the adult weight, but by 2 years it's grown to 75% of the adult weight. It's quite a bit, isn't it? This increase results from the development of a denser, more fully packed brain. So there are two processes at play here. One is that the neurons put out many new fibres that connect them with one another, creating branches as we call them. And certain brain cells called glial cells activate myelination. This is where they coat the neural fibre with an insulating fatty sheath called myelin, which speeds up the efficiency of message transfer. And we'll talk about myelin and connections becoming myelinated right throughout the lifespan, because it has multiple effects if the myelination process doesn't happen well and or is affected by certain diseases. So one important function of the brain is to control the infant's state of sleep and wakefulness. And the brain also regulates the amount of stimulation the infants experience, both internally and externally. And periodic sleep helps the infant to shut out external stimulation and thereby allows them to obtain general physical rest. And as you're probably aware, babies sleep a lot, and we'll talk about that in a moment. Sleep patterns of infants. Newborns sleep on average 16 hours a day, but it does vary with individuals, and it would be interesting for you to actually check with your parents, with your mother in particular, to see what you were like as a sleeper and how much you actually slept, just to get an idea about what was average and what was normal. By 6 months of age, you're averaging 13 to 14 hours per day, and then by 24 months or 2 years you're averaging about 11 to 12 hours a day. It's much more than when compared to the average adult, who sleeps around about 6 to 8 hours today. Infants divide their sleep into active and quiet periods of sleep. So if we look at the sleep changes that occur from newborns right through to adults, active sleep is called REM sleep, REM, or rapid eye movement, which twitchings usually accompany it, and you can actually see the eyelid twitching during the REM period. Researchers believe that REM sleep provides a way for the brain to stimulate itself, which is vital for the growth of the central nervous system. And this is important for infants who spend a lot of their time asleep and relatively little of their time in alert states. Non-REM sleep is the quieter kind of sleep, and infants they breathe regularly and more slowly, and muscles become limper. We can see that adults and infants differ in the proportion of time spent in sleep states compared to wakefulness, and also the type of sleep. Even though infants sleep for long periods, the periods of sleep may be quite short, and not uncommon for infants to wake every 2 to 3 hours throughout the whole 24-hour period. It's been suggested that unpredictable sleep of infants may be due to immaturity of the baby's nervous system. Irregular sleep is not a problem for most infants, but irregularities of neural activity may be related to Sudden Infant Death Syndrome, or SIDS, commonly known as cot death. Visual acuity. So infants can see at birth, but they actually lack the clarity of focus or the acuity characteristics of adults with good vision. They can see more clearly at short distances, especially 20 to 25 centimetres, but things at a distance are often blurry even at 6 metres, and the visual acuity improves steadily during infancy, reaching about what we call 20/20 adult vision by 6 months. Three theorists, Southgate, CISPR, Kaufman and Johnson, suggest there's markedly different processing of objects and faces in the infant brain, so infants respond preferentially to simple face-like patterns. So we have these things called survival reflexes, and basically infants are born with several reflexes or automatic responses to specific stimuli, and some reflexes such as sucking help the baby to adapt to new life outside of the womb, hence they're called survival reflexes. Others may be vestiges of earlier evolutionary stages, and we call these primitive reflexes. So the reflexes are the first observable signs of newborn motor responses, and they serve as survival mechanisms for protection and the seeking of food. Some reflexes persist throughout life, and others disappear after the first 6 months. So the primitive reflexes, the relationship between postural reflexes such as swimming, stepping, the Moro, the Babinski and later voluntary movements is much debated. There's some argument that early reflex movements provide the basis for later voluntary movements, but the jury's still out on that one. Paediatricians test reflexes in assessing the neurological function of the newborn. It also forms part of the APGAR test as well. Reflexes are critical diagnostic indicators during the early months of life, as they indicate neurological integrity. And newborn reflexes that persist over many months may suggest damage to the nervous system and specifically to the cerebral cortex. Now the motor skills. Motor skills are voluntary movements of the body or parts of the body, and they're grouped according to the size of the muscles and body parts involved, and this is something you'll get very used to, and if not have already done so in other subjects. Gross motor skills involve the large muscles of the arms and legs and the torso, and they involve things like crawling, walking, jumping. And the fine motor skills involve the small muscles located throughout the body, for example, reaching and grasping. And the sequence of which skills develop follows two general trends. The first one's called cephalocaudal principle, which is basically the head to tail, which means upper parts of the body become usable and skillful before lower parts of the body. So, for example, babies learn to turn their heads before moving their feet intentionally. Then the second one is the proximodistal, which is near to far. And that means that central parts of the body become more skillful before peripheral parts. So babies, for example, learn to wave with their entire arm before learning to wiggle their wrists and fingers. Some motor milestones deviate from these trends and are therefore individual differences between babies. But most babies, for example, most babies crawl, but some go straight from rolling to walking. So once again, you can ask your mother, did you tummy crawl, or did you bottom crawl, or did you go straight from rolling to walking? Just to see how you fit in amongst the general motor milestones. Some research suggests that babies reach for things with their feet before their hands, and that's possibly because hand reaching requires more practice, so it's not always a strict cephalocaudal pattern. There is an importance here between nature and nurture as well. So there are various milestones that create a predictable level of development for most children. I suppose we would call the most reasonably predictable development is walking. By 12 to 13 months, most children take their first independent steps, and well before 2 years they can often walk backwards and sideways as well as forwards, so rapid development continues. So once again, you can check with your parents as to when you first started to walk. Some kids start walking as early as 10 months, and some start walking as late as 18 months or 2 years. So yeah, it varies. It's quite varied. There are, interestingly enough, cultural and sex differences in motor skills. The differences between the cultures and between the sexes are, though, not always large or dramatic. So certain African cultures provide opportunities to sit upright and practice their walking when held in a standing position, and this leads them to learning to walk earlier than Australian and New Zealand toddlers. Some Aboriginal children in traditional communities develop stronger head and neck muscles, which allows them to sit unaided much earlier. This is usually due to child-rearing practice of not supporting the head while carrying the infants. And while there's evidence to suggest that there are sex differences in infant motor development, the evidence is inconsistent and inconclusive. The World Health Organization longitudinal study between 1997 and 2003 that actually tested 8,500 infants monthly from 4 to 12 months found that gross motor milestones such as sitting without support, crawling, standing and walking with and without assistance was assessed in 5 countries. While differences between countries were observed due to culture-specific behaviours, no significant and consistent differences in milestone achievement age between boys and girls was seen. How infants use their time does so show some difference. So boys showed more activity than girls, and that's a trend that starts even before birth. So in utero, boys are often a bit more active inside their mother's uterus. Girls spend more time using fine motor skills, but also social influences through, for example, parental praise for gender-appropriate behaviour. But some of these behaviours very early and prenatal some part of the difference is genetic and some part of the difference is environmental. Individual differences are likely to be stronger than gender differences because as groups, boys and girls are more alike than different. It's important, therefore, for people such as teachers to respond to the qualities of individual children rather than working on stereotypical gender averages. And I think this is a really important point for your cohort of people coming through this exercise and sports science degree. So whether you're wanting to go into PE, teaching, physical training, physical therapy, physiotherapy, strength and conditioning, exercise physiology, it's really important that you keep very cognizant of the fact that we want to respond to the qualities of the individual. We want to make sure that we're not stereotyping kids and placing them in you're a boy and you're a girl, therefore you must, whatever. Very important to keep that in mind. So another piece around development here is a thing called object permanence, and while research has confirmed the main features of this particular theory of object permanence, it really looks at infants' cognitive understanding, and it was a theory that was designed by or discovered by a fellow whose name is Piaget, and we'll be looking at Piaget quite a bit throughout the whole lifespan development. And there was a criticism that Piaget's stages confuse motor abilities with cognitive or thinking abilities. Object permanence implicitly depends on a child's ability to conduct a physical search for an object. It may not lack an understanding of the object permanence, but the physical mean to demonstrate it. So, interesting whether this is a cognitive or a physical position. So there's been a new test by a researcher called Balajian, and his test requires only a visual search rather than motor coordination. Infants habituated to the sight of a toy car sliding down the track from left to right, and in the middle of the track there was a screen obscuring the part of the track. During habituation, babies shown the screen raised several times to show that there was nothing preventing the car from going down the track. But then when they're shown the events, there's a possible and an impossible event. So in the possible event, a toy mouse is placed behind the track. In impossible, it placed on the track but later removed prior to the trial. So at 3.5 months, they showed surprise at the re-emergence of the car following the impossible event. So this was interpreted as infants understanding that, or the assumption about object permanence. So basically that just because there is evidence of an object permanence, however, doesn't always mean that children are ready to reason about it. So basically the the first child is shown an incline track with the screen, which can be raised and lowered, they become habituated to watching the car roll down the track behind the screen and out the other side. And in the two test events, the possible event was that in this one test condition, the toy mouse is placed behind the tracks, but is hidden when the car rolls past. And in what they call the impossible event, so in this other test condition, the mouse is placed on the tracks but is secretly removed after the screen is placed, so that the car seems to roll through the mouse. So it's really about whether they're able to understand that whole process. And I have a great little YouTube clip on object permanence, which makes this all seem much more sensible and much more understandable. So just pause for a moment and take 2 or 3 minutes to watch the YouTube clip. So when we look at Piaget's theory of object permanence, sometimes there's a confusion about the lack of motor skills with cognitive limitations. However, early evidence of object permanence does not mean that young infants are ready to reason about hidden objects in a way that older children, older adults do. So for Piaget, full object permanence involves conscious problem solving or a deliberate search for the object. There is evidence to suggest that memory affects infants' performance of various cognitive tasks more than Piaget realised. So for example, imposing only a few seconds delay when an infant searches for an object can reduce the success rate. By establishing that infants are susceptible to such limitations, the research strengthens the idea of continuity in development. So that is, infants resemble adults, and weakens the idea of change. That is, that infants are somewhat different to adults. It also suggests that a belief in object permanence may have a different meaning for younger and older infants. So, for example, the ability to track an object visually and the reappearance of an object from a physical search. But once again, it's much more readily seen and observed in that YouTube clip that hopefully you just watched. So, behavioural learning. So there's two types of learning that we look at, and one is called classical conditioning and the other one is called operant conditioning. So learning basically is a change in behaviour that results from experience. Infants enter the world with inbuilt capabilities that enable them to learn, and they learn through two basic behavioural forms. One is classical conditioning, and this is an innate voluntary reflex that makes classical conditioning possible for the infant. So a neutral stimulus is paired with a stimulus that leads to a reflexive response. Once the baby's nervous system makes the connection between the two stimuli, the new stimulus will produce the behaviour by itself. And this was introduced by or identified by a researcher called Pavlov, hence the famous Pavlov's dog experiment. And in the next slide you'll see the YouTube clip which explains it very clearly. Operant conditioning is where learning where an organism acts or operates on the environment through spontaneous voluntary behaviour. So the reinforcement received increases the probability that the behaviour will occur again. Imitation is, and once again there's some good examples of that in the YouTube clip that's coming up. Imitation is the second key of infant learning, and researchers have suggested that imitation may reflect the baby's need to communicate, as through imitation infants explore their social world, forming social relationships. So the behaviours of the adult and the child reinforce each other. Infants also have the ability to imitate an important foundation, or it is an important foundation for social interaction in later life. And we do say there's a good saying, and that is children model the behaviour of the adults around them or close to them. So imitation is a good part of that. Here's the YouTube clip on conditioning, which is very well worth a look. So basically, to summarise chapter 4, we're looking at the average newborn who's often red looking and covered in a waxy substance. We're looking at how infants sleep almost twice as much as adults, and their need for sleep decreases, and they've got a different type of sleep. Infants are also born with a number of innate reflexes, and they develop motor skills such as reaching, grasping and walking quickly. And we also looked at different types of learning, so classical conditioning and operant conditioning. So that basically ends chapter 4. So I look forward to meeting you all next week, and then continue on face to face with you for the rest of the semester.